Welcome to Unit 4, Integration Part 2, Definite Integrals, U-Sub, Advanced Integration. Calculus AB, Part 1. What happens to the value of a definite integral when the bounds swap places? If the bounds of the definite integral from a to b of f of x dx switches to the integral from b to a, the integral becomes negative. In other words, when the bounds swap places, the sign changes. Part 2. What is the additive property of definite integrals? The additive property of definite integrals is pretty intuitive. It means you can add them. Guess what the integral from a to b of f of x dx plus the integral from b to c of f of x dx equals? It is the same as the integral from a to c of f of x dx. Part 3. What is the first fundamental theorem of calculus? The first fundamental theorem of calculus links the concepts of differentiating a function with the concept of integrating a function. Differentiation is the inverse of integration. Differentiating calculates a function's slopes or rate of change at each point in time. Integration calculates the area under a function on a graph. The theorem is represented by this equation. The original function f of x is equal to the derivative of the integral from a to x of f of t dt. Part 4. How do you evaluate a definite integral? A definite integral is an integral that has bounds from a to b. To evaluate a definite integral, you must use the formula integral a to b of f of x dx equals f prime of b minus f prime of a. If you evaluate this, you will get the definite integral. Remember that the integration constant, c, is only used when evaluating indefinite integrals. You would not use the integration constant for a definite integral. Part 5. How do you evaluate a definite integral when the function is within absolute values? To evaluate the integral of the absolute value of a function from a to b, first find the points where the function equals 0. You do this because that's where the function switches from positive to negative or the other way around. Then break the integral into sections at those points. Let's say you're going from 0 to 6. If the function equals 0 at 2 and 4, you'd split it into 3 intervals. From 0 to 2, from 2 to 4, and from 4 to 6. Now check the sign of the function in each interval. If the function is positive, just remove the absolute value. If it's negative, remove the absolute value, but make the expression negative. Finally, evaluate each section separately, then add them all together. Part 6. What is the second fundamental theorem of calculus? The second fundamental theorem of calculus goes as follows. If a function f of x is continuous on an interval from a to b, and f of x is its antiderivative, then the definite integral of f of x from a to b is equal to f of b minus f of a. As a formula, it looks like this. The derivative of the integral from a to x of f of t dt is equal to f of x. If the upper limit is a function, use the chain rule. The derivative of the integral from a to g of x of f of t would be f of g of x times g prime of x. Part 7. What is the derivative of an integral when both bounds are constants? One is constant and one is a function, and when both are functions. When both bounds are constants, the derivative of the integral is simply 0. When one bound is a function and one is a constant, you must use the chain rule. The formula looks like this. When both bounds are functions, you must apply the Leibniz rule. But that is for a different video, as it goes beyond Calculus AB. Part 8. How do you find the average value of a function? Firstly, the average value can be taken of a function over a closed interval from a to b. The formula is this. 1 over b minus a of the integral from a to b of f of x dx This formula finds the total area under the curve from A to B, then divides by the length of the interval b minus a. This gives us the average height. Another way to think about the average value is as being the average height. Part 9. What is the mean value theorem for integrals? The mean value theorem for integrals goes as follows. If f of x is continuous on the closed interval from a to b, then there exists at least one point c in the interval from a to b, such that the value of the function at c is equal to the average value of the function over the interval. The formula looks like this. F of c equals 1 over b minus a of the integral from a to b of f of x dx. Part 10. What is U-substitution? When is it used, and how do you use it? U-substitution is a technique used in integration to simplify the integral by making a substitution that transforms the integral into a more easily solvable form. U-sub is used when the integral contains a composition of functions. To use U-sub, follow these steps. First, choose u. This is usually the inner function or a part of the integrand. Then differentiate u to find du. Substitute the expression for u and du into the integral. Simplify this new integral. After that, integrate with respect to u. Substitute back the original expression for u and add the constant of integration. Part 11. How do you know what to choose for u? How do you change the x-bounds of a definite integral to be u-bounds? When picking u for u-sub, consider the composition of functions in the integrand. Look for parts of the integrand that resemble a function and its derivative, and after substitution, ensure that the integral becomes simpler to evaluate. If the function is not simpler to evaluate, then you probably need to choose another term for u. To change the x-bounds of a definite integral to be u-bounds, simply evaluate u at the original bounds. Part 12. What are some strategies to use when u-sub alone does not work? 1. Integration by parts. The formula is integral of u dv equals uv minus integral of v du. 2. Trigonometric substitution. 3. Partial fraction decomposition. This makes a complex-looking integral easier to evaluate by splitting it up. 4. Completing the square. This simplifies the integral and makes it possible to integrate. 5. Use of symmetry, even or odd. 6. Numerical integration. Essentially, use Desmos. 7. Look for special forms and use integration rules. For example, reversed power rule. Part 13. What is the antiderivative of tangent x, cotangent x, secant x, and cosecant x? The integral of tangent x evaluates to natural log absolute value of secant x plus c, and can also be written as negative natural log absolute value of cosine x plus c. The integral of cotangent x evaluates to natural log absolute value of sine x plus c. The integral of secant x evaluates to natural log absolute value secant x plus tangent x plus c. The integral of cosecant x evaluates to negative natural log absolute value cosecant x plus cotangent x plus c. Part 14. What is the antiderivative of an exponential with a base other than e or a constant? Let's take u to be some function. The integral of a to the u evaluates to a to the u over natural log a plus c. Part 15. What are the integral arc trig identities? The integral of 1 over square root a squared plus u squared du equals arcsine u over a plus c. The integral of 1 over u squared plus a squared du equals 1 over a, arctangent u over a plus c. The integral of 1 over absolute value u square root u squared minus a squared du equals 1 over a, arcsecant, absolute value of u over a plus c. Part 16. What is the goal of solving differential equations using separation of variables, and what is the process of solving them? The goal of solving a differential is to find the unknown function or family of functions that satisfies the equation. To use separation of variables, follow these steps. First, separate the variables onto either side of the equation. Move all of the y terms to one side and all the x terms to the other. Then integrate both sides. After that, solve for y. In some cases, apply the initial condition if provided. Part 17. What is a slope field, and how do you create a slope field given a differential equation? Firstly, a slope field is a graphical representation used to visualize the solutions of a first-order differential equation. To create a slope field given a differential equation, first, identify the differential equation. Then choose a grid of points. Evaluate the slope at each point. Draw small line segments at each point's slopes. Repeat with enough points to capture the general behavior of the solution. Part 18. What does it mean for a rate to be proportional to another variable? How would you set up the equation? Let's say dy over dx equals k times y. dy over dx is the rate of change. Y is the variable whose rate of change is being described. K is the constant of proportionately. When k is greater than 0, the rate of change is positive and grows as y increases. This indicates a positive proportional relationship. When k is less than 0, the rate of change is negative and decays as y increases. This indicates a negative proportional relationship. And that wraps up Unit 4, Integration Part 2 in AP Calculus AB. We covered everything from definite integrals and U-substitution to the fundamental theorems of calculus, slope fields, and differential equations. Remember, integration isn't just about finding area. It's about connecting accumulation, motion, and change across math and science. If you found this helpful, make sure to like, subscribe, and turn on notifications so you don't miss the next unit. And if you're reviewing, check out the shorts on each part of this unit for fast, focused practice. As always, keep practicing, keep asking questions, and I'll see you in the next one.